Data communication. Networking is all about data communication. Now, last time we understood that networking is you creating a channel and passing through data from one point to the another. We also took a quick look at how of the various hardware that can help us in networking. So we saw the likes of the network cables, the devices we need, the type of networks we need. Now today we are going to enter the data communication of the network. In fact, the how a network is arranged, or the types of arrangement we can form in a network. Data communication. When we talk about data communication can come in so many aspects. So it's all about sharing information, whether local or remotely. When we talk local means face to face, or a person around you physically where you can share data. The remote means over a very long distance, so you are not near. The person might be in country C, you are in country A. Then you share, you exchange data. That's termed as remote data communication. Right. Now, in data communication, we have so many things we have to consider. We have 5 basic points we have to take note in networking and in data communication. The first thing we will take note is the message. The second one is the sender. The third is the receiver. The fourth is the transmission medium. And the fifth, it is the protocol. With these 5 rules, or with these 5 components, you can establish a data communication system. So a data communication system is you using network to transfer from one point to the another. Now let's take a quick look at our first component of data communication. Now the message. When we talk about the message in terms of data communication or networking, it refers to the information you are sharing, or the information you are going to communicate to the other counterpart. So we have point A, point B. You want to transfer data from A to B. Now the data you are transferring, or the information you want to send from A to B, is the message. Now this message can come in so many forms. We have the text, numbers, pictures, audio, and video. So it doesn't matter what kind of message you are sending, it is the data. So it falls under the component, the message. In data communication, for you to establish a successful communication or a successful network, you will need your message you want to send from one point to the another. Please, any question with the first component? Right. The second component is a sender. In every network or in every communication, there should be a sender. One should be receiving and one should be the one sending. Now, the sender will send the message that's in the form of data, either by text, numbers, pictures, audio, or video from one point to the other. Now, it can be a computer. So wherever you want to send it from, computer, workstation, telephone, handset, video camera, and so on. Irrespective of the devices you want to send from, you can actually be the sender. So you be the sender and transmit that data or the information you want to send from point A to point B. Any question on component 2? Right, on the component 3, we have the receiver. And what the receiver is the one receiving the message you've sent. So point A, point B, Let's say the sender is at point A, the receiver is at point B. Now, point A, that's the sender, will send a data in the form of any of these text, numbers, pictures, so on, through a medium to the point B. So the point B, the one receiving, is called a receiver. And a receiver can be the same thing. The receiver can be a computer, a workstation, telephone, handset, television, and so on. Any question with component 3? Now, component 4, transmission medium. Transmission medium. Our last meeting, I made mention of when you are creating a network, you actually create a channel to send one data or one information from one point to the another. Now, the medium through which the data is being sent is called the transmission medium. Now we realized the last time, we have a whole lot of examples of transmission medium. We have the twisted pair wires. So I made mention of the cables. We have the coaxial cable, the twisted pair cable. The twisted pair is the wire you use to connect from your computer to the network port in your internet lab or where in some offices. Now the coaxial cable is the one that's behind, similar to the one you connect to your TV poles and your antennas. And we have the next one to the fiber optic cable, the fiber. So we have these MTN, they have these strong cables that they lay to connect people. It's called the fiber cable. We also have the radio waves. We also talk about the signals, whereby it travels through the vacuum, where it's not protected and it can be distorted and so on and so forth. So those are the medium through which your message is going to move from the sender to the receiver. Any question with point 4? That's the fourth component. Now, the fifth component here, we will take a look here. It's very important. It's called protocol. Every network has a protocol. In fact, it's a set of rules that govern the data communication. Now, data communication is the same as transferring one data from one point to another. It needs to have an established rule that protects us. For example, when you want, in a real life example, when you are speaking French to someone who doesn't understand French, there is no way the person is going to understand you. The vice versa, when you are speaking English to a Frenchman and the Frenchman doesn't understand English, there is no way you are going to establish a successful communication. In networking or in data communication, there is a protocol. It's a set of rules that govern this data communication. It makes sure it established an agreement between these two devices you are using. For example, you want to connect your phone to your laptop using a Bluetooth medium or using a cable. Now, there has to be a protocol whereby your phone, so let's say, for example, some of the real life protocol we have is an Android phone and a Windows laptop. You can see when you connect your Android phone to your Windows laptop through a cable, there is a communication where you can actually see your phone on the laptop and whatever information you want to take from it. Now you realize when you connect your Android phone to your Mac, there will be no connection. It will come as charging because there is no protocol establishing an agreement between your Mac and your phone. But when you try to connect an iPhone and a Mac, it will be able to connect because there are some rules that can establish an agreement between these two devices. So in every network, there has to be an agreement between the two devices to say, okay, The language you are speaking, I understand, and the language you are speaking, I understand. Therefore, there has been an agreement and there has been rules that's going to govern whatever data we are going to share. Please, any question on the protocol? Because it is very important. There has to be an agreement between these two devices or these 2 points before a data communication can take place.
No, sir.
Yes.
So, sir, with the protocol, is it that
Okay.
there is a device in the machine that is not allowing, let's say for instance, you connecting an Android to a Mac. Yeah, there is a device in the machine that is not allowing, or there are sets of like programmings that they themselves, the Apple company has done that you can access maybe an Android on a MacBook. Like, how is it done? Are there rules? How is it physical? I don't know. I don't know how to put
Okay.
it, but like,
Yes, I understand you, Godwin. So, in terms of you are talking data communication in terms of these devices. Now, you see the Mac OS normally uses the MacBook, or if you are using iMac 2, normally or usually comes with their Mac OS, and the iPhone 2 is using iOS. Now, they have connection. So between these two code or these two operating systems, it's the same operating system you are using virtually, but one is made specifically for phone and one is made for a laptop or for a desktop. So when you connect a MacBook to an iPhone, there is a connection, there are protocols, or there is a connectivity between it. They've done it that way. But Windows operating system is different from Mac. It's different from iPhone's operating system. And for you to establish that a connection or understand, so it's like you are connecting a Frenchman to an Englishman. Where the Frenchman is going to speak, the Englishman won't understand. Now, when you connect, you will need an extra translator. You see, sometimes some people can connect their Android phone to their MacBook using a third-party software. So here it means a translator. So someone who can stand between the Englishman and the Frenchman to translate the language for them. Please do get it. But in Android and Windows, there has been a connection already. So they've included this set of rules in their operating system. The standard, when you connect an Android phone to Windows, it automatically comes. Godwin, are you okay?
yes, sir, yes, I've understood. Sir. Meaning it's the
Okay.
operating system that is the factor.
Yes.
Thank you. The operating system. Okay, thank you.
Again, the next, and we are moving on, is data representation. Data representation. This is very important. Now, first, we've taken a look at the components of data communication. What involves in establishing a network or data communication? We said the message, that's in the form of text, numbers, pictures, audio, video. The sender, the one sending it from one point, the receiver, the one receiving it, the transmission medium, the medium through which the data is being sent from one point to another. And we have the protocol, the agreement establishing between these two senders, the receiver and the sender. Now, the data representation. That means here literally we are taking the message aspect and dig into it. Now, information today comes in different forms, such as text, numbers, images, audio, video. Now, for example, in your various media platform, you can send, most of them you can send, in fact, all of these, you can send text to friends, numbers, you can send images, audio, videos. Nowadays, it seems all the media you can send each of them. Now, what is the general, the building block of these messages? When you talk about test, what is test? You need to understand the building blocks of these things we use in our communication. Most of us will be like, oh, test is just combining letters to form a word. Then no. In networking, test is not just test. We are going to go through each of these data to understand what we do. So the message you send to friends through either text or numbers or emails, you need to understand what is the building block of what you are sending, or how the computer sees what you are sending. Maybe you are sending how are you. You see it as how are you. It's not how are you that you are sending. It's a whole different thing you are sending. But to you, the user, it is how are you are seeing. Now, our first representation we will take is text. Text. So when you ask someone text, the person will be tempted to say, oh, A, B, C, D, and you combine them to form a word. So let's say when you want to spell a boy, you say B-O-Y. You go your way. So that's a test. I want to test the boy is going to school, so I'll just take my keyboard out, my phone, I'll test on WhatsApp, the boy is going to school, then I'm done. As a networking student or as someone who knows networking, you need to know what you are testing. It is not just combination letters. Now, in data communication, text is represented in bit pattern. The text you are seeing, they are represented in computing as zeros and ones. Now, there are different sets of bit patterns that have been assigned or represented text symbols. So the letter A you see, it has the zeros and ones patterns. The letter B you see, it has the zeros and one pattern. The letter C you see, it has the zeros and one patterns there. So if you realize, when you send a lot of information to, let's say, text, for example, okay, a real life example you can take notice. When you open your Word document, then just type maybe say one line of sentence. Then after that, the file, go and check the file size. Now, you open it again, you record the first file size. The next, you open it again, then type so many things in the Word document. Then you save it and go and check the size again. You see the size has increased. The size of the file has increased. If you think it is just text you added, why is it the size increasing? No. Those ones are zeros and ones. Every letter you see is represented in zeros and ones, and it is calculated in bits. So the letter A can be 32 megabytes, the letter B can be 45 megabytes. We've combined them. That's why when you test more or when you write more documents, your document become more heavier. Right. Now let's dig inside. Each set is called a code. The process of representing symbols is called coding. But the coding system is called Unicode. I know some of you have come across this word. Unicode is basically used in coding. Now, which uses 32-bit to represent a symbol or character used in any language in the world. So any language in the world, the letters we use they have their bit represented. So any letter you are using, you can actually, when you dive deeper, you can actually calculate the size of the letter or the size of the word. So maybe you are writing, the boy is going to school. You can actually calculate the size or the space it is taking. The boy is going to school. So every letter you see is a bit pattern. It's not just text you are seeing. They are zeros and ones that you can actually calculate the size of it. Now, in networking, we send this bit, or when you establish a connection, you send this bit or data through the medium. It is calculated. Now it takes data, it takes that. Now, one thing is, why is it that when you don't have data, enough mobile connection, and you text, it doesn't go? Because it needs space, or it needs data, it's calculated and deduct the mobile bundle it needs from it. So let's say you have bundle 50 megabytes. Or okay, for example, you don't have you don't have bundle, then you text your friend, how are you today? Then you press send. You see it won't go. But you have 50 megabytes, you buy 50 megabytes. Then you come, you test, how are you? Then when you on your data, you see it will go. Yes, it needs data to transfer data. Now, these are called the American Standard Code for Information Interchange, the ASI. It was in fact developed some decades ago, few decades ago, and they are used in 127 characters. So for one, we will actually also do conversion of binaries to decimals, the calculation part. So we will get there, and we will be able to calculate the size of word, the word we form. So when you say go, the size of go, so maybe it is 2 kilobytes. So we will calculate all this using the bits and the ASCII. The next one we will take a look is numbers. Numbers. In fact, numbers are also represented by patterns. However, it's not used to represent numbers. They ask the American interchange. It's not used to represent numbers. But numbers here are in fact converted to binary to simplify mathematical operations. Now, these zeros and ones, it is that has been combined to form binary. So when you see 1, or when you see 10, when you see 11, when you see 12, we have it zeros and ones. You can convert that 10 you are seeing to zeros and ones, because we want to make calculations so simple. That's why all these have been converted to the binary for you to be able to read and perform your calculation. When your teacher gives you 100 plus 2, you can just do it, oh, it is 102. But no, in computing, it is not 102 you are seeing. There are zeros and ones, and when you are being allowed to do in a real or in a basic or decimal on the zeros and ones calculation, you will get confused. That's why it has all been converted to binary numbers. Now we will also learn how to convert these binaries to decimals. So that when you see a number, so when you see 99, you convert it to 8 zeros and ones. So you see 99 there, so you can convert it to 01011. So each of these, so in networking, for you to transfer numbers or text, they are transferred in bit patterns, zeros and ones. Please, any question? So real life example, when you transfer, when you send someone, how are you? You've transferred zeros and ones. But to make it more easier for you to read and a person to read, that's why it comes in that form, the ASCII form, the American Standard Code for Information Interchange, so that you can read it. But the computer or the medium, the data that's being sent, it's zeros and ones. Images. If we are saying text, numbers are in zeros and ones, what are images in? So what is the representation? Hello. So what's the representation of images? Now, images are represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels. In short, a pixel is a small dot, just a dot. Every image is dot. So it's composed of matrix of pixels. When I say matrix of pixels, but whole number of dots that have been combined together. So if you have actually analyzed an image before, When you go deeper, you see the image you are seeing, it is dot, 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 that has been arranged in such form for you to see the image. So every image you see is a dot. So it is a pixel. And these pixels are dots, small dots you are seeing. So when you draw a cat or when you see the image of a cat, it's a pixel. And in this pixel, there are small dots in that shape you are seeing. Right. The next thing here you go on is audio.
Hello, sir.
Audio. Yes.
So, sir, with the 8 pixels, can we also calculate it?
Okay, with the bit pixels, you can calculate it, but that calculation is different from the first one. The bit with the bit pixels, in fact, you actually use the 2-bit patterns, which I you don't need to actually go there because that one will be used in advanced networking, and when you are actually those in the in picture designing industries. Do you get it? So that one they calculate it, yes, in 2-bit patterns. So you can see it here. You can use 2-bit patterns. Yeah, that one is I'm far from here. Okay.
So, sir,
Yes.
like it's from the previous slides or when you were discussing about the other one, the calculations in the binary, the zeros and ones.
Okay.
I heard you saying that, let's say for instance, if I have typed a message, let's say hello, say, and then it contains maybe maybe 3 megabytes. It takes 3 megabytes from my data, my personal data, to send to
Yes.
the person I'm sending to. So
Yes. So it's this.
Okay, so you can.
Okay. For you to understand it clearly, now when you are downloading a file from the internet and it is 1 gig, then you have 2 gig. You realize at the time of you finish downloading, it will be left with less than what you had. So you see, it has actually deducted the size of the file from the data you have. That's the same concept here. You get it?
Yes, sir. So with the picture aspect, let's say for example, I have to do the same thing, but we don't know how to calculate it.
Yes. So the picture, so if you have 10 megabytes data and you see some pictures come with sizes. So you can snap a picture and you go and check the size is about 4 megabytes. Yes. So when you send a picture and you have 6 megabyte data, you realize after sending the picture, you'll be left with either 2 megabyte or less than 2 megabyte because it has taken its size from the data you're already having. You get it now?
Yes, sir.
Yes. Now, audio. What are audio? If images are represented in pixels and text and numbers are represented in bit patterns, what are audio also represented in? Now, audios are represented in scripts or signals. So they are represented in continuous signals. So for example, I want to. Okay, we'll actually leave it there. So in audio, for example, even when you use, it says here, when you use a microphone to change voice or music to an electric signals, we create continuous signals. No, in audio, all it uses is signals. So the voice I'm bringing out is signals. The signal then it's converted for you to hear wherever you are. So in every audio to in signals. So when you are transferring an audio from one point to another, it passes through the medium using signals. As the other styles will use bit patterns and pixels, audio uses signals. Okay. Now the next thing to we take is video. In video, when we talk about video, video is recording or broadcasting a picture or a movie. Video can be produced as a continuous entity, or it can be a combination of images, each discrete entity arranged to convey the idea of motion. So in image here, image can be more pictures that are being combined together. So if it's more pictures, can be measured in that or in motion. So image can actually be sent through signals. So it can be converted through signals, video, through signals from one point to another. Please, any question with the data representation. So these are the data representation we send through all networks from one point to another. Any question on this? Right, the next thing we are going to take a look is data flow. Data flow. How is data moving from one point to another? What are the types of data flow we can have? Here we have three types. We have the simplex, we have the half duplex, and we have the full duplex. The simplex, half duplex, and full duplex. Right, our session is going to end. We will join again. Kindly check your Slack channel for the new link. Thank you.